You learned this somewhere. A classroom, a documentary, someone who sounded certain. Jupiter protects Earth, the largest planet in the solar system, out there catching the asteroids and comets that would otherwise hit us. A bodyguard, a shield, the reason you're alive. You believed it. So did your teacher. So did the textbook. So did most astronomers. For 50 years. Nobody tested it. Not directly. Not once. And when somebody finally did, the numbers suggested Jupiter might be doing the opposite. So if Jupiter was never the shield, what was the whole world actually watching the night everyone decided that it was?
July 1994. Every major telescope on Earth turns toward the same object. Hubble, Keck, observatories on 6 continents. Even the Galileo spacecraft, still millions of miles from Jupiter, rotates to look. 2 years earlier, a comet had wandered too close. Jupiter's gravity didn't push it away, it pulled it apart into 21 separate fragments, strung out in a line like beads on a wire. Now, the beads were coming back. For 6 days, one after another, they hit Jupiter at 60 kilometers per second. That's New York to Los Angeles in about 90 seconds. The largest fragment released more energy than every nuclear weapon on Earth, several hundred times over. It left a bruise in Jupiter's clouds wider than our entire planet. It was still visible months later. And if you watched it happen, you thought what everyone thought. That could have been us. Something out there stopped it. That was the day you stopped asking.
You should know how easy this was to believe. Jupiter isn't just big, it's incomprehensible. More than 1,300 Earths would fit inside it. Its mass is more than twice every other planet in the solar system combined. Saturn, Neptune, Uranus, Mars, Venus, Mercury, your planet, every moon, every asteroid. Add all of it together, Jupiter still outweighs the pile. Twice. That much mass bends the space around it. Drop a bowling ball onto a stretched bedsheet. Everything that rolls near it starts rolling downhill. So of course it catches things. Of course it's a shield. It's obvious. It's intuitive. It was never tested. So how does an idea survive 50 years without anyone testing it? Not by being hidden. This was everywhere. Textbooks, documentaries, classrooms, museum placards. It survived because it felt finished. The story was satisfying enough that the field filed it under solved and moved on to questions that looked harder. It took until the late 2000s before 2 astronomers, Jonty Horner and Barry Jones, actually built the simulations and asked the simplest possible version of the question. Remove Jupiter, count the impacts. They published the results as a series of papers. They titled them Jupiter, Friend or Foe, Part 1, Part 2, Part 3. 50 years of certainty, and the first real test showed up with a question mark in the title. Here's what the simulations found. Jupiter does shield you. That part is true. From long-period comets. Those are comets on orbit so wide that a single lap around the sun can take 10,000 years. Objects falling in from the Oort cloud, a shell of frozen debris wrapped so far around the solar system that sunlight takes more than a year to reach it. Jupiter is genuinely, measurably good at throwing those back out. Now, the number that breaks the story. Long-period comets are about 5% of the total impact risk to Earth. 5. For 50 years, you thanked Jupiter for guarding the door. It was guarding the smallest door in the building. So what's coming through the other 95%? Near-Earth asteroids, the category that ended the dinosaurs. On their own, roughly 3/4 of the impact risk you face. And here, Jupiter does something nobody put in the textbook. It doesn't block them. It aims them. Picture pushing a child on a swing. One small push at exactly the same moment in every swing, and the arc gets wider and wider. You're not pushing harder, you're pushing in rhythm. Jupiter does that to asteroids. Certain orbits in the asteroid belt line up with Jupiter's own.
Same nudge, same point every single lap. And over millions of laps, the arc stretches.
You can see the result from Earth. There are lanes in the asteroid belt that are almost completely empty. Astronomers call them Kirkwood gaps, stretches of orbit where nothing stays. Nothing stays because everything that ends up there gets its orbit stretched until it crosses Mars, and then crosses you. Those empty lanes aren't proof of a shield. They're the exit ramp. The bodyguard, or the thing loading the gun. Fewer comets from the outer dark, more rocks from the belt next door. Two effects, pointing in opposite directions. We were never wrong about the physics. We were wrong about the story we wrapped around it. And right now, nobody can tell you which one wins. Which brings us to the actual question. What if Jupiter disappeared? Not exploded, not moved, simply gone. Tonight, while you sleep. Here's what happens to you. Nothing. Not nothing yet. Nothing. No tremor, no tide, no change in the sky except one bright point missing from it. Jupiter is 300 times Earth's mass and never closer than about 365 million miles away. Its pull on you right now is weaker than the pull of a large building standing across the street. You'd find out from a headline. The change starts where nobody's watching. Out in the belt, millions of objects just lost the largest gravitational influence on their orbits. The rhythm stops. The push stops. Nothing collides. Nothing explodes. The rocks simply start drifting along paths slightly different from the ones they were on yesterday. It's the quietest catastrophe imaginable. A few centimeters per second of difference, multiplied by millions of objects, multiplied by time. And nobody is watching the belt. Then the comets arrive. The long period ones. The 10,000-year orbits. The ones Jupiter used to catch and throw away. Now they cross the outer solar system unopposed. More of them reach the inner planets. More of them cross your orbit. That 5% Jupiter genuinely was protecting you from starts growing. And then the slow part. Jupiter's gravity is one of the main things holding the current shape of the solar system in place. Take it out, and the remaining orbits begin rearranging. Not collisions, not chaos. Drift. You'd never see it. Neither would anyone you'll ever meet. It's a disaster measured in geological time. So, would you be safer without Jupiter? We don't know. That's the real answer. Not a cliffhanger, not a dodge. 50 years after we decided Jupiter was on our side, the honest position is that it reshapes the risk instead of removing it, and the totals are still being argued over in journals right now. Go back to July 1994. All those telescopes, all those people watching fireballs bloom in Jupiter's clouds and thinking, it took that hit for us. They weren't wrong about what they saw. They were wrong about what it meant. They were watching the largest thing in the solar system, after the sun, do the only thing it has ever done. Change where things are going. Sometimes away from you, sometimes toward you. For 4.5 billion years. Never once on your side. Jupiter was never Earth's bodyguard. It never applied for the job. We gave it the title. And then we stopped checking. Next episode, another invisible system you were told was protecting you. Subscribe so you don't miss it.